Hello everyone, this is the beginning of my Linux privilege escalation series. Before beginning, I would like to tell you that all of these techniques and more are there on the internet, but I find it hard to find a one-stop place for as many as possible. And with that aim, I'm beginning this series, and I will very likely update them as I learn and discover. Another reason for doing this is because at some of the places the instructor or the author has made several presumptions about the knowledge of the reader or the listener, which did become an obstacle for me since sometimes there were some small things that I had no idea about. So I had to pause the lecture and refer, like look out for online references, study about them, and then continue back again. But in this series, I will try my best to explain every concept that comes along in simplest of words so that you don't have to do that. So let's begin with our first video. The core of this technique lies in the misconfiguration of basically the file permissions that we have. So if we try to list the files that we have over here in this directory, we have a file name file1.txt and we have a directory that is called tools. So if we look over here, we can differentiate between the file and directory because of the presence of this particular alphabet D over here in the beginning. So this denotes that this entry is a directory, and the dash basically or the hyphen indicates that this is a file. Now in Linux, the permissions are in the set of three. The first three permission, these three first three alphabets are for the owner of the file. Second set of permission is for the group that owns that the file might belong to, and the third set is for all other users basically. So this last three alphabets, these represent for all other users apart from the owner and the group that the file belongs to. So now if we, okay, so basically over here R stands for read permission, W stands for write, and X stands for execute permission. So RWX, like we can see that the owner has read, write, execute permission. The group that the file belongs to has only read and write, and all other users have read, write, and execute. So now these permissions also have numerical value associated with them. So the R permission has the value of 4, the read permission has value of 4, the write permission has value of 2, and the execute permission has a value of 1. So when we define these permissions in their numeric form, it is called an absolute mode, which is more preferred for some reason. And if we refer to the permissions with their alphabetical way, then it is called the symbolic mode. Now let's take an example and try to understand this better. Now let's say if I try this particular command, chmod, let's say 5 6 and 2 over file1.txt. So on execution of this particular command, basically what will happen is this first digit, this basically sums up the permissions for this particular file for the owner of the file, because we have first we have the owner, then we have the group the file belongs to, and then we have all of the users. So if we look at 5, now read, write, and execute 4, 2, and 1. So 5 can be a sum of 4 and 1 only. That is the only way we can have 5, by using only ones all of those digits. So 5 would mean 4 plus 1, that is read plus execute. So this means that the owner of this file should have read and execute permission. Over here we have 6, which means 4 plus 2, which means read and write. So it should, this particular permission set should stay the same. We had 5 for the owner of the file, which means read and execute, so the write permission should go away. And we have 2 for the all other users, which means only the write permission, so we should have the read and execute permission revoked. Now if we try to do ls-l on this particular location, we can see we have only write permission and execute permission for the owner of the file. We have read, write permission for the group, and only the write permission for all other users. So this thing worked. The other way to do this thing is to basically we also represent all the, like we use U, G, O. So U stands for owner, G stands for group, and O stands for all other users basically. And if we use A, so that includes UGO altogether. So if you want to list, like if you want to have the same set of permissions for all these three different segments basically, then we can use the A flag. So let's try some examples. So if let's say chmod, so over here we can see that the root does not have write permission. So if I want to add the write permission for basically the owner of the file, so I can do chmod u plus w on file1.exe. Now one more thing over here, if we want to add a permission, we will use plus sign. If we want to remove a permission, we will use minus sign. So I hit enter and I list the permissions. We can see I have the right permission over here. Now if I want to, let's say I want to revoke the right permission from the group, so I will do chmod g minus w on file1.txt. So on doing this, as you can see, I have my right permission removed. Now let's say I want to remove let's say I want to remove, or maybe let's say I want to add the read and execute permission for file1.txt for all other users. So I can do chmod o plus rx, sorry, o plus rx on file1.txt. Now as I can see, like I have read, write and execute permission for all other users. Now let's say I want to set like read, write permission for all like the owner, the group, as well as all other users. So I can do chmod a plus rwx on file1.txt. As you can see, I have complete set of permissions for all the three different segments. So this is the basics of Linux permissions. Now let's try some real life scenario. So over here I have a Docker container that is running the latest Ubuntu image from the Docker hub itself. Now let's say that I'm setting up a server, and let's first talk about the password file. So basically the etc password file is one of the crucial file in any Linux system. The reason is that it stores like the information about all the users that are present on the system. Earlier it also used to store the password, but not nowadays. Nowadays basically the etc shadow file has all the hashes of the password stored in it. So if we try to cat out this particular file, so now if we try to cat this particular file out, we will see that over here we have all the users listed. So if we look at the syntax, the first entry is basically before the first colon, we can see this is root, that is the username. This was the place where the password used to get stored, but not nowadays. Nowadays the hash of the password is stored in the etc shadow file. The third entry is basically the user ID. The fourth entry is the group ID. Root user has 0 as user ID as well as group ID. From 0 to 1000 UIDs, these are reserved for the system processes, whereas in GID basically any new user will have basically like a group ID starting from 1000. That is like a general thing. Over here we can see the name. Basically when we create a new user, we enter their user like first name, last name and all that information. So this is called the geckos, and that information is stored over here. This is the root directory of this particular user, which for this one is root, and this denotes the shell that must be executed when this particular user logs in. So as we can see that we have a base user, and it has a UID of 1000, and over here also 1000. We have the geckos field empty. We have our home directory and this. So let's basically see how this can be exploited. Let's say that while setting up the server, I messed up the permissions for this particular file, and somehow some way I gave write permission for the etc password file. Now if I do ls-l on etc password, I can see that I have write permission for all other users. So now let's just switch on to a base user and see yes, so how can we can exploit this thing. So when I look at this particular file, I have write permission. Now basically if I have write permission on any on a password etc password file on a system, and if I and of course I know that like a root user basically has UID and GID as 0. So if I just edit this particular thing and then basically just log as myself again, having known the right password, I practically get the root of the environment, and this is like one of the most simplest case scenarios, which can also be found uh, in various CDFs on basically like you can find such conditions in easy level CDFs in CDF time, or you can even find such conditions in some of the boxes on Hack the Box. There are some examples which have this particular scenario in their environment. So this is like a very easy way to escalate the privilege if we have such misconfiguration. So this was it for this video, and I will also drop some links in the description so that you can refer for if you have any if you want to read more about, or if you want to read about the permissions basically in a more in-depth manner. There are some really amazing resources from Oracle, and I will list them in the description. You can check out over there, and let's just stay connected for the next video, and we will definitely be discussing all of the privilege escalation for Linux and Windows. That's my plan for now in the coming videos. So yep, stay tuned.